All right, I've got your Workshop 5 quiz help. Okay, so let's go ahead and start off with this first question here. Okay, the first thing we're going to want to do is we're going to want to graph the function by using the table of coordinates. Now the table of coordinates is here. It's giving you -2, -1, 0, 1, and then 2. And what it wants you to do is just put these into the equation. And this is your equation already here. So all I'm going to do is I'm going to take this -2 and plug it in for x. So what that looks like is 2/3 to the -2. Now, this exponent goes in to every single thing here. All right? So that's really a 2 to the 1 and a 3 to 1. So when I do that, the exponents multiply because this is saying everything inside of here this many times. So I get 2 to the -3 over, to the -2 over 3 to the -2 because 1 times -2 is -2. 1 times -2 is -2. And this has an exponent as a 1 always because 2 to the 1 power. Okay, so if I just, if it's negative on the bottom of the fraction, the denominator, then it's going to be positive on the top. And if it's negative on the top, or the numerator, then the exponent's going to be, if it's negative on the numerator, it's going to be positive on the denominator. And this is 3 squared, which 3 squared is 3 times 3, which is 9, and 2 squared is 2 times 2, which is 4, so that is 9/4. All right, so you do the same thing. I'll go ahead and demonstrate this next one. So I have 2/3 to the x power. Now to the -1 is what I want to put it in. So to the -1. Again, you do the same thing. These both have an exponent of 1, and this -1 goes into both of these, which is 2 to the -1 over 3 to the -1. So remember, if the exponent is negative in the numerator, it is positive in the denominator. So that is 2 to the 1. If the exponent is negative in the denominator, it is positive in the numerator. And you are able to move things up and down around like this as long as it's all multiplication division. There's no addition and subtraction on here. Okay, so that's just 3/2, and that's the answer there. All right, so let's go ahead and try to use 0. So for 0, I put in 2/3 to the 0 power. Now again, these have 1s here. 0 multiplies by here. So I get 2 to the 0 because 0 times 1 is 0. 3 to the 0. So 2 to the 0, anything to the 0 power is 1. Anything to the 0 power is 1. So 1 divided by 1 is 1. Okay? Now, 2/3 to the first power. So now I have 2/3 to the 1 for this next one here. And that's just, again, the 1s multiply. So that's really easy. It just goes 2/3. All right? And finally, let's do to the 2 power. So this is, again, 2/3 to the second power. And remember, exponents are 1. If they don't have an exponent, that's what we put. And we have 2 times 1 is 2 over 3 times 1, which is, 2 times 1, which is 2 again. So that's 2 times 2 is 4, and 3 times 3 is 9. So we get the same thing, 4/9, except if you notice, this is 9/4, and this is 4/9. This is 3/2, this is 2/3. All right. Next one. Now we're going to supposed to pick the correct graph of what it looks like. Well, let's kind of look and see. We have a graph here. You can do a couple of things. First of all, I'm going to just talk about what a graph like this looks like. This is a fraction exponent, but it's positive. So if it's positive, you know it's going to start high, because if I put numbers in here, that's going to start high, and then as it goes negative, then that's going to come on and end low. As it gets to 0, what's going to happen? It's going to get close to 1. So you can look at C here, and you can plug these in. If you plug all of these in, at -2, it's 9/4. You look over here, -2. Well, there's no negative. Negative 9/4 is over here, and there's no graph up here, so we know that's not it. We go to here, same thing. We put in -2 on x, and we should get out 9/4. Again, -9/4 is a little bit bigger than 2, so it's something about here. Maybe -9/4 is about here. Again, there's nothing part of the graph here, so not that one. All right, this one's a little bit more interesting. -9/4 is again about right here, and again, it's about at -2, so that satisfies, that's okay. -1, 3/2. So 3/2 is about -1.5, and it looks like it might be okay. 0 is going to be at 1. That looks like it might be okay. 1 is at 2/3, and that looks like it might be okay. And 2 is at 4/9, which is about 1/2. So these kind of look like they might be okay. But I'm going to go ahead and check these out as well. It's hard to tell on these graphs because then when you check these points all check out. But if you notice, this looks really linear, the way this is drawn. Again, I'm not a huge fan of Math Excel on these. Looking at this, once you expand it and make it larger, you can do that. Hopefully you know how to do that on the technology to enlarge it. It helps, and it's a lot easier to distinguish between these two, because when you look at these at face value, they look, hey, this works, they all work. But when you look at this, this is truly looking like a straight line. And that's not what this is, because that would be a y equals like a 2x plus 3, or a y equals -2x plus 3, something like that, something linear, where this looks like an exponential function. An exponential function looks like this. If it's a y equals some sort of a fraction, like an a over b to the x, it starts high and it ends low. Okay? Let's go to the next one here. Number 2. Okay, it says solve the following exponential equation by expressing each side as a power as the same base and then equating the exponents.